Okay, so today we are going to finish up section 3. We've already learned how to divide using synthetic division and long division. So today what we're going to do is learn two theorems, and those theorems both use synthetic division. So this is the first theorem. It's called the remainder theorem, and there's a little typo here. There should be an equal sign here. So if a polynomial f of x is divided by x minus k, then the answer you get for the remainder is the answer, or the y value of the f of k. So we're going to see what this means. So what we're going to be doing is, yesterday they gave us the information as x, this would have been x plus 2. And then we would have had to take the opposite when we do the synthetic division. So when it's presented to you as f of and then a number, we're going to actually use that exact number in our synthetic division problem. So again, I'm going to take all the coefficients, including the constant, and write it in my synthetic division box. See if I can straighten this up a little. All right, now, in WebAssign, it's not going to have it written like this. It's going to say, find the value of this when k equals -2. So whatever k is, that's what you're using in your synthetic division problem. So now I'm going to go ahead and I'm going to do the synthetic division. Bring down my first coefficient. I'm going to multiply. Put the answer here, add the column, multiply again, put the answer here, add the column, multiply again, and then my remainder is -9. When I use the remainder theorem, the answer that I get for the remainder is the answer to my problem. So when you're doing questions 1 and 2, it's going to have a part A and a part B. Part B, they just want you to write what you got for the remainder. Part A, they have instructions in the problem to format your answer in this manner. X minus k, q of x plus r. So the q of x, this is actually the quotient or the answer to my synthetic division problem. And then you would put plus the remainder. This is the remainder. And I know I need to get out of the gallery there. Let me get out of that. So then this is plus remainder. Over here, you would be putting in, because they told you that it was -2, we flip the sign and you would be putting in x plus 2. Now, to get the quotient, I need to come back to the bottom of my synthetic division box and add back in the variables. So let's go ahead. Remember, this is the remainder. This is the constant. This is the x. This is the x squared. So my answer here for the quotient is going to be 3x squared plus 2x plus 1, and then I put the -9, which is the remainder. When you put it into WebAssign, you're going to put parentheses around the quotient. This is the q of x. This is the r. And then you put the x minus k here. And that's going to be the x plus 2. So for part A, this is how you would enter your answer. So you're still doing the synthetic division, but they want you to key it in this format. All right, so for number 11, it's the same thing as number 10. So I know I wrote on top, but that's a 4 there. So I'm going to do synthetic division with the 4. I'm going to write all the coefficients in here and the constant. I'm going to bring down. Going to multiply. Gonna add up that column, multiply again. I get 104. Gonna add the column, I get 101. Multiply again, and I get 404. Add the column, and I get 396. Let's go ahead and put the variables back in. Remainder, constant, x squared. So I end up now with 4x squared plus 26x plus 101 plus 396. So for WebAssign, you would add parentheses around this, and then you would take
Jake, Bedard, is the bus for soccer?
Okay. So now this is how you will enter part A for WebAssign. And then now for part B, you just type in the remainder. So 1 and 2, this is how you answer them. They're going to tell you which number to divide by, and then you just turn it into that polynomial, put the remainder at the end, and what you're dividing by at the beginning. Now, again, number 3, I know I didn't say this in the video, but on WebAssign, question number 3, they're just going to they'll give you a function, like say this same one, and then they're going to say, instead of finding f of 4, they'll say find f of 4, and then they'll say find f of 1, find f of 0, and then you just plug that in and do a synthetic. And then the answer is going to be the remainder on all these. And that's all you type in is a number in each one of the boxes. Yes? Yes, it is. Thank you. Yes, 4x squared. Now, be careful because with WebAssign, you leave off one little thing like this, or if you leave off a sign, it's going to mark it wrong. So just be careful. Watch what you're writing. You know how picky WebAssign is. So in cases like this, if you were to have made this mistake, but you had it in your work and you used up your 3 tries, I would go back and give you the points because you had the square in your work. So this is why it's important to, keep your work there, because sometimes you just forget. All right, next theorem is called the factor theorem. Notice when we started out this problem, notice how it started out as an x cubed. And then once I got my quotient, it is now an x squared. By doing synthetic division, it brings it down a power. So that's our goal, is by dividing by a factor that we know is true, it'll keep breaking it down till we finally get it to an x squared, to a quadratic function that we can either then factor, use the quadratic formula, complete the square, or use the square root method to get the other factors. So let's take a look. And what this theorem states is that if a polynomial f of x has a factor, that when you do synthetic division with it, if it gives you a remainder of 0, then that means it's a factor. If I get a remainder that's anything except 0, then it's not a factor. We're going to be doing synthetic division to find all of the solutions, or all of the zeros, or all of the roots. These are all meaning the same thing, by using synthetic division and breaking it down a degree by degree until we can get it to quadratic. Now, if you look back, now the challenge here is when you're given questions using this factor theorem, the questions could be asked with different words. So for example, the question could say, find all of the roots, which is right here. Or it could say, find all of the zeros. Or it could say, find all of the solutions. Or the question could say, and this is for SAT too, could say find all of the x-intercepts. All 4 of these are going to be the same thing. They all mean the same thing. They expect you to do exactly the same thing, which is what I'm about to show you. So when it says find the roots, find the zeros, find the solutions, find the x-intercepts, it's all looking for the same answer. When we do this process, the answers we get are where our graph touches the x-axis. There are x-intercepts. They're also called the zeros of the function. They're also called the roots of the function. And they're also sometimes called the solutions of the function. So they all mean the same thing. So let's go ahead and try this. So when we use the factor theorem, what we're doing is you're either going to be given a factor, and what we need to do is test it out. See if that gives us a remainder of 0. Remember, when it's given to you as an expression, this is where we're doing the opposite, because the solution or the root is really x equals 2. And this is what I need to divide by. Put all of the coefficients in here. And now I start my synthetic division. To see if this is a factor, remember my goal is to make sure that the remainder is 0. I'm going to bring down. I'm going to multiply. And I get 4. I'm going to add the column. I get 11. I'm going to multiply. I get 22. I'm going to add the column. I get 18. I'm going to multiply. I get 36. I'm going to add the column. I'm going to multiply. I get 18. I add the column. I got a remainder of 0. So you would say, yes, x minus 2 is a factor of this polynomial. Now, the leading exponent, when this is written from greatest to least, this exponent tells me how many factors I'm going to come up with. So this polynomial actually has 4 factors, which mean it has 4 roots, which mean it has 4 solutions, 4 zeros. That exponent tells me how many solutions I'm going to get. Now, sometimes it might be repeated. You might get 2 solutions that are 0. And we'll see this later on. But today we're actually going to get 4 separate answers here. Next question is asking me to do the same thing. It still wants me to check to see, is this x plus 3 now a factor of this polynomial? So again, I would set it equal to 0. And I'm dividing by the x minus 3. 2, 7, negative 4, negative 27, negative 18. Bring down. I'm going to multiply. Bring down, or add up. Multiply. Add the column. Multiply. Add the column. Multiply. Add the column. Again, I got a remainder of 0, so I will say yes, x plus 3 is a factor of that polynomial, or of that function. Now, I'm going to do what the factor theorem states, is once I know one of the factors for sure, I am going to take what I got after I divided, so this quotient. So now I'm going to work with this one. The 2, if I put my letters back, R, C, X, X squared, X cubed. So now I have 2x cubed plus x squared minus 7x minus 6. So this is my function now. I can't factor it yet. It is a 4-term polynomial, but I can't factor by grouping here. So I need to do another synthetic division problem with another factor to bring it down 1 more degree to an x squared. Now I'm actually going to go back because I already know that positive 2 is a factor. So I'm actually going to do a synthetic division with the factor from number 12. So let me write now just the coefficients. And the place that I got this 2 from is going to be from number 12, because I already knew that x minus 2 was a factor. So now I'm going to do synthetic division with it and make sure that I get a remainder of 0. So I'm going to bring down, I'm going to multiply, add the column, multiply, add the column, multiply, and I get a remainder of 0. Yes. Now I'm going to add back the variables. Remainder constant x, x squared. So now I have 2x squared plus 5x plus 3 equals 0. Now, I have a quadratic equation or quadratic function. I can find the remaining 2 factors by factoring this, or by using the quadratic formula, or by completing the square. I'm going to factor it because it's factorable. I can actually factor this. Let me go ahead and guess and test. Put a 2x here, put an x here. Then I'm going to put 3 here and 1 here. 2, 3, and these are my factors. So if the question said to list the factors, I have these 2. I have this one that I divided by here. And then I had the one that initially broke it down, this one, the x plus 3. These are the factors. However, on WebAssign, numbers 4 and 5 are going to say list the zeros. So now we have to take this one step further and set each of my factors equal to 0. So I set x plus 3 equal to 0, x minus 2 equal to 0, 2x plus 3 equal to 0, and x plus 1 equal to 0. I'm now going to solve for x on all 4. Subtract 3. X equals negative 3. Add 2 on this one. Subtract 3. Then divide by 2. X equals negative 3 over 2. Or you could make it a decimal, negative 1.5. And x equals negative 1. Now, when you key this answer on numbers 4 and 5 on WebAssign, the instructions in the problem say, give the answer a comma, the answer a comma. So it just says to separate your answers with commas. So you would key this in as negative 3, comma 2, comma negative 1.5, comma negative 1. This is how you would enter it into WebAssign. No x equals, just a number, a comma, however many solutions you end up with. Anybody still need this? So if you go to the next slide, here is the graph of that function. Notice the 4 answers we just got. These are our x-intercepts. These 4 points are called the zeros, they're called the roots, they're called the x-intercepts, they're called the solutions. Be aware of that. Pretty good? Let's try another example. Now, this time, they're still giving us one of the factors. So I can do my synthetic division using this factor. However, if the instruction said to use a graphing utility, then you would key this function into it to see where your graph hits the x-axis. Notice this is the one they told me to use, okay? So if you didn't have, I'm also going to teach you a technique to find them without a graphing technology if they don't give you the factor. But for right now, we're giving you the factor, and we're going to tell you which one to do your division with. So let's go back. And now let's go ahead and do synthetic division using -3. Now, remember that we need to account for every single spot in the function. This one is missing x squared, so don't forget to hold its place with a 0. So the coefficients I'm going to enter are 1, 0, -19, and -30. It's like a countdown, x to the third, x squared, x, and then the constant. Bring down the first coefficient, multiply, add the column, multiply again, add the column, multiply again, add the column. Now, if we did not get a 0 in this last spot, then we would have had to have picked another number, or we did something wrong. Now I'm going to put back my variables. Remainder constant, x squared. So this becomes x squared minus 3x minus 10 equals 0. I now have a quadratic function that I can either factor, if it's factorable, sometimes it won't be, use the even root or the square root method, completing the square, or quadratic formula. If my quadratic function can be factored, that's the method I always use. It's the fastest way. This can actually be factored into x minus 5 and x plus 2. Notice my original problem had an x to the third power. That meant that there were 3 solutions. The first one was given to me. So these are my 3 factors for this polynomial. However, on WebAssign, it's going to ask for the zeros, and that's what it also asks for here. So now I take each of the factors, set them equal to 0, solve for x equals -3, x equals +5, x equals -2. Again, on WebAssign, you're going to do -3, 5, -2. Do not put x equals, just put the numbers separated by a comma. And again, if you look either up at the tiny graph that's there or you go to the next slide, again, it is the graph of that polynomial, and you will see that your graph touches the x-axis at these 3 numbers. Now, I'm going to show you how to do numbers 6 and 7 in your WebAssign homework. That's what I'm going to do the next example. I know it's not in the notes. I'm going to, or maybe it is. Is there a handwriting? So this is that graph. This slide in your notes. Okay, so this is the one I'm going to do. Now, in WebAssign, it's not going to give you one of the zeros. The way that you're going to get one of the zeros to do your synthetic is you're going to key it in a graphing calculator. So if you want to key it in Desmos, then just touch the silver dots. That'll give you the ordered pair or the solution that you need to do synthetic division with. Now, if you go to your next slide, so I'm going to take my function, x cubed minus 2x squared minus 2x plus 4. I now know that my exact 0 is the positive 2. That's what I'm going to do synthetic division with. So I'm getting one of the answers from the graph, and I'm doing synthetic division with it. And I saw that I had the order pair 2, 0. I'm now going to do synthetic and turn this into a quadratic equation that I can either use quadratic formula, factor, or completing the square, or square root method. Let's bring down the 1. Let's multiply, add the column, multiply, add the column, multiply. I get a remainder of 0. So this tells me that x minus 2 is a factor. Now I'm going to add back my variables, remainder, constant, x squared. X squared, I'm not going to put plus 0x, I'm just going to put minus 2. I now need to find the remaining 2 factors of this quadratic. So what I can do here is I could move the 2 over because this is not factorable. Use the square root method. So my 2 solutions, or my 2 roots, are plus and minus square root 2. But I need to turn those back into factors. So my factors turn into x minus square root 2 and x plus square root 2. In addition to the one which was from the 2, 0. So for part C on 6 and 7, this is how you enter the answers. So this part you do by hand. You don't put the decimal equivalents here. Part A had the decimal equivalent to the square root of 2. Yes?
We need to go up to like all the making steps.
So this file is in Canvas.
Oh,
If you look in the module, this slide's in there, but you can see it. It's in the module. It says part 2, 3.3 part 2 notes.
yeah.
Okay.
Thank you.
You're welcome. Okay, and then here is the graph of that. Now, on WebAssign, it tells you key it in a graphing calculator. Then it's going to say for part A, write down all of the solutions from your graphing calculator and round them to 3 decimal places. So for part A, you're going to type in negative 1.414, comma, positive 1.414, comma, 2. That's what it's expecting you to do for part A in your WebAssign homework, is just key it into a graphing utility, get those 3 numbers, or if it's 4, and write them down. Then part B is asking you for the exact 0. Notice these guys right here. Oops. These are actually radicals. They're estimated answers. So the only exact 0 here is the 2. So for part B, you're going to type in 2. You're looking for the integer answer, or even a terminating decimal answer like 1.5. But if it's got more than just 1 decimal place, that is not an exact answer. This is actually, once we do it by hand, this is actually negative square root 2, and this is actually positive square root 2. And that's what you're gonna be entering into part C, but I'm gonna show you how we get those answers for part C. Let me go back to the problem. Looked at the graph again. Here's your graph. So again, when you're doing this on the test, I'm gonna want the radical answer. I'm not gonna want the decimal answer. So the file with these graphs are in Canvas. It says the name of the file is part 2.
But Natalie Fairfoot, can you please report to Student Services with your belongings? Natalie.
So you have 7 problems for this lesson, or for the second part of the lesson. And again, it's due the Monday when we return from break. We're also scheduled to take a test that week on that Thursday.
And Jamie,